Hello everyone and good day. In the last video, I've shown you how to create logic circuits using circuit verse. In this video, I'm going to show you examples of those logic circuits that are commonly used in uh, digital systems. We are going to create these logic circuits later on using circuit verse. So one of the popular or most commonly used uh, circuit is called a binary decoder. A decoder is used in the output side of a digital device, particularly to convert binary into decimal or hexadecimal, or even into a 7-segment display. The main component of a decoder is an AND gate. So for example, we can decode the value 1101 by using an AND gate which has 4 inputs, one of which has a complemented input, basically where the 0 is located. So in this example, we have a 3-bit binary decoder, which will convert into decimal. And here's the example. No? So for example, the first AND gate will decode 0000. The second AND gate will decode 001. The third AND gate will decode 010, and so on and so forth. The second example of a circuit commonly used is called an encoder. An encoder is the reverse of a decoder, where it converts hexadecimal or decimal into binary. That is because people can only understand decimal or hexadecimal. So they have to be, from input, they have to be converted from decimal to binary, and into output, they have to be converted from binary to decimal or 7-segment display. So an encoder circuit usually uses an OR gate. Like in this case, we have a 4-bit encoder which translates the digital number 0 to 9 to A0, A1, A2, and A3. Okay. The third example is an enable switch. An enable switch is like a faucet, where when enable is low, the receiving variable y will not get the value from A, because anything ended with a 0 is a 0. However, when enable is high, the y variable or the y outputs will receive the value A, in the sense that anything ended with 1 is itself. Okay. The next circuit that we are going to discuss is the half adder. A half adder is called a half adder because it adds 2 bits. In this example, the XOR gate is used to do the summation, and the carry is done by an AND gate. Like in this example, if you are going to add 0 and 0, the carry being an AND is a 0, and the sum being an XOR gate is a 0. 0 plus 1 is a 1, and the sum is a 0 because anything ended with a 0 is a 0. And an XOR gate will output a 1 if there's a 1 in the input. 1 plus 0 is 1, okay, and will carry out a 0. And 1 plus 1 is 0 basically because an XOR gate will output a 0 when both of them is 1. And the carry is 1 because anything ended with all ones will be 1. That's called a half adder. The third is a full adder. A full adder is like a half adder in the sense that it also adds bits, but this time it adds 3 bits. Okay. Now the out is now ANDed together. Okay, with is ANDed is created using an AND of C and A and B. Take note, no, it's ANDed with C and it's A B ANDed with the XOR of A B and C. Okay. So anyway, the XOR gate is still used. The 3-input XOR gate is still used to compute the sum, and the series of sum of products is used to compute the carry. So in an adder subtractor on arithmetic logic unit, The full adder as a white box is used to create register addition. Like in this case, we are presented with a nibble adder where A is added with B using the full adder, and it will output a sum and a carry. Now, this is a subtractor in the sense that when subtract is 1, okay, B is converted into 1's complement. Okay, so remember that we can add subtract a number by adding its two's complements. In this case, B is complemented by an XOR gate, and the additional one is added to the first carry of the first full adder. We'll create a circuit like this to demonstrate the process using circuit burst. Okay, so in the next video, we are going to configure a 7-segment display and create a decoder that will convert uh, binary values into decimal. Bye for now and see you then.